Okay, so looking at these, so going to kind of look at all these formulas. The a times b to the power of x, we have seen that before. That's what we've worked with. And we have done these, they just haven't been all typed out like this. They haven't been laid out like that. So if it was a growth, we would do 1 plus the rate as a decimal to the power of x. The teacher would put these together. She also did it with t because the majority of the time that exponent is going to represent time. And then obviously the decay is 1 minus r if it is decay. For the half-life and double life, okay, so these are new ones that we're looking at. We'll tell you the majority of the time I will not, the double life one I will not use. We will have an example of one, so I'll kind of go through it the way that I go through it, the way I think most people would go through it, and then I'll show you how you would actually use the formula. But the half-life one, you will need to know that, and you'll need to know what K stands for. So underneath that, let's define that. And all K is going to stand for is the half-life of a substance. Let me kind of explain exactly what half-life means. Most of these problems, they're going to be very chemistry and or medical type sounding problems. It's going to be talking about somebody having to take a medicine or something. The half-life of something is the time it takes for the amount of whatever to reduce by 1/2 or to decay by 50%. So they're always going to be a decay problem, hence the base being 1/2. Alright? And so on those problems, you're always going to have two things that's going to be measured in time. You're going to have the half-life, and then you're going to have whatever time period they're asking about. Alright, so you take 2 Advil, and it has a half-life of 1.5. So K would be 1.5. And maybe the question asks, how much of that Advil is still in your system after 10 hours? So you would put 10 in for T. So you're going to have 2 things that are going to be in time. You need to know which one of those to put it in for. Alright? And we'll see a double life and a couple half-life problems throughout these questions. But these first couple are just basic. The 1 minus R, 1 plus R. Alright, so Gracie, will you read number 1 for me?
Enrollment at Lakeland High School is 2,220 students, and the annual rate of growth is about 11%. How many students will be enrolled 2 years from now?
Okay, so Joe, what is my A value on this problem? Okay. Chance, is this a growth or a decay? Growth. Alright, I talked about on 11.1 day. Whenever you're going through a word problem and you find the word that is telling you, hinting at it, whether it's growth or decay, to put 1 plus or 1 minus above it. 1 plus if it's growth, 1 minus if it's decay, obviously. And then, Zach, 11% as a decimal would be what? 11% as a decimal would be what? 0.11. So on top of the problem, you've kind of already built the equation as you're reading through it. All right, it's your A value, which is 2,220, times 1 minus 0.11, which is 0.88. Sorry, thank you. Which wouldn't be 0.88 anyways, but so you'd have 1.11 to the power of x. Okay, is that the exact same? I had this question come up last class. Because this is the way the formulas are written.
Yes.
Is that the same as that? Yes. If you want to write it that way, that's fine. Okay. I think on the skills check, I had some people writing it that way. That's fine. So, And it says, what is the population in 2 years? So I'd put 2 in for X. So go ahead and do that. Practice putting that in. Please don't practice painting your fingernails with your pencil. It's never a good idea, and make sure that you have a calculator as well. Thank you, Zach. And Morgan, how many students would there be after 2 years? 2,735 students. Okay. Go ahead and attempt number 2. All right, so going through this, Bree, what would my equation be? Okay. Then I would plug to figure out how much it would be worth in 3 years. I'd put 3 in for X. And Josh, how much would the Mustang be worth after 3 years?
19,480.
80.
79, so you can round it to
79. I think it was, what did we say, Morgan? 7, 8?
Mine says 80.
Okay. On C it says time it takes for the value to fall below 10,000. So how can I solve that? Put in y equals. I go to the table and I look for the first x value when the y value is below 10,000. So how long would that take, Miss Bryan?
9 years. Who answered? For me. Someone answered for me.
I said Miss Bryan. I think Ryan thought I said Ryan. So she might have said something. It's okay, Gracie.
I have to do that.
Alright, so looking at this, let's go ahead and go through this. So, what is the initial number of bobcats? 200. It doubles. So my B value is what? 2. Make sure that you know that. Okay, if it says tripled, it's 3, quadrupled, it's 4, whatever. So I've got 200 times 2 to the power of x. To figure out how many bobcats there are for the population in 4 years, what am I going to put in for x?
8? Because it doubles.
4 or is it 8?
8.
8. Because there are 8 6-month periods in 4 years.
Wait, or I can just know times 2, right? Or is that not right? I just guessed right on accident? Yeah.
Okay, so that would tell me that there are, what does that come out to? It's
51,200.
Okay. Now, let's go through this before we answer C. Let's go through this equation as if we had used the double life formula. Okay, so I would still have the same initial value. I would still have, it's still doubling. But now I'm going to do that T over K. So what is my time?
Wait, do you mean 200 for that? Not 200?
Sorry, I do mean 200. Thank you. So now I'm doing that exponent, which is T over K. So what's the T? What's the time period that they're asking about? 4 years. So what would I put in there? Would I put 4?
No, you put 12 times 4.
12 times 4, which is 48. Because you need the time period and the half-life to be the same unit of measurement. Both of those are in months. You can't have put in 4 because that's years, and then put in 6 because that's months. Alright? I can do it that way. Could I also do it like this?
Yeah.
Now they're both in years. 6 months is half a year. Both of those will give me 8. 48 divided by 6 is 8. 4 divided by 1/2 is 8. Okay. And then I can go to C. It says, when will the population exceed 10,000 bobcats? So I'm going to go in. I'm going to find when it exceeds the when the y value goes above 10,000, which is what?
Oh, 5, 6.
Do what?
Like 5 to 6 or 6.
6.
Something's not right.
Alright, so let's go to the back. So kind of start looking at half-life stuff. Joe, will you read that paragraph for me?
A well-known example of exponential decay is the decay of radioactive isotopes. Iodine-131 is a radioactive isotope used in medical treatments. In 8.02 days, half of the iodine-131 in a sample will have decayed. Therefore, the half-life is 8.02 days. Every 8.02 days, the quantity is multiplied by 1/2 or 2 to the power of -1.
Okay, so there again is kind of the explanation of half-life, and it gives us the formula right there that we're going to use. Know that this and this is the same thing. 1/2 and 2 to the power of -1 is the same thing. When I'm going through this problems, the majority of the time, or pretty much all the time, I'm going to be using that because I think most people are more comfortable dealing with a fraction that has a positive exponent than a whole number with a negative exponent. So I'll probably be doing that. Your A, even though it is the capital A, that's still your initial value. Okay, that doesn't necessarily change. So, for it says the patient has to take 50 milligrams of iodine-131 to treat his thyroid disease. How much is left in his body after 12 days? And when does the amount drop below 1 milligram? So, what am I going to put the 50 in for? A. So I'm going to have 50 times 1/2. What am I going to put 12 in for?
12 days.
Okay, so that's T over 8.02. I want everybody to put that in. Alright, it's raising a fraction to a fraction. That's something you hadn't done a lot that you need to make sure you're comfortable doing in the calculator. So I want everybody to practice putting that in. I am going to go ahead and put it in the other form as well up here with 2 to the power of -1. Once you get that, go ahead and do B as well. How much remains in the body after 12 days?
17.7.
Okay. So make sure that you got 17.7 milligrams on A. If you did not, let me come around and check to see how you put it in your calculator. How many days would it take for it to drop below 1 milligram? Okay. Real quick, before we get to that though, what is going to be different between this right there that I just put in the purple box and what I'm going to put into y equals?
The 12.
The 12 is going to be what?
X.
X.
Sorry, can I go to the bathroom real quick?
Mm-hmm. Okay, so on that you should have gotten that it would take about 46 days. So let's go down to the last problem. So know that this is a different problem. So the half-life is not 8.02 on this. Carrie, will you read it for us?
After 3 days, 1.25 mg of the substance remain.
All right. So let's write the equation. Garrett, what is the initial value?
8 milligrams.
80. What is the B value?
3 days.
Nope.
Or no, 1.25.
Nope.
Is there even a B?
There is. If only it was somewhere on there. What does that mean the B value is?
1/2.
1/2. What is my T?
3.
3. What is the K value? Nope. That's how much is left after 3 days. The K value is the time it takes for it to be cut in half. Do what? We don't know it, so it's X, and we want to know what X value exactly. So how do I solve this? Okay, I can put my equation into y equals. So I'll put y1 80 times 1/2 to the power of 3 over x. And then what do I do after that? Okay, so I can scroll up and down until it equals 1.25. Can anybody find 1.25? No. So how else can I solve this? Well, eventually, yes, we will, but we won't get into how to do that by arithmetic or by algebraically doing it until next unit. So what is another way? By using the calculator.
Graphing.
Okay, I can go to the graph, but what else do I need to put into y equals?
1.25.
In y2, I'm going to put 1.25, and I'm going to go to the graph, and I want to see where they intersect, which it's been a while since we've done this, so
Yeah.
make sure that kind of look up here and follow along with me. So in y equals, I'll kind of start over from the beginning here. So in y1, I'm going to have 80 times 0.5 to the power of 3 divided by x. Your exponent may look a little different. I can't do the little fraction thing on this one. Y2 is going to be 1.25. Now to help see it a little bit better, it won't be a lot. I changed my y minimum to -2. You don't have to do that. And then I go to the graph. There's my exponential. There's y equals 1.25. And the answer that I'm looking for is where those two cross.
Yeah.
So I'm going to hit second, trace. Option 5 is intersect. And then I'll hit enter, enter, enter. And I find that the intersection, the x value where they intersect is 1/2. Okay, so you should have gotten that x, or the half-life, is half a day. If you got that, I want you to attempt B. If not, whenever I'm answering when will it drop below 1 milligram, what equation am I going to put into y1? 80 times 1/2. I'll still have my initial and my b value. What is my exponent going to be?
X over
X over 0.5. So I put that into y1. Now I can go to the table and I scroll down and I'll find that you should find that between 4 and 5 days is how long it would take for it to drop below 0.1 milligrams.